It is a pleasure to be here and to talk about the topic about which I have been researching maybe for more than 20 years now. Some of you probably were not born by that time. And it's funny to think about that. And I will not bring detailed research results, but I aim to bring you a reflection about the situation that we have, and I would like to challenge you to think differently from what we have been doing in the past. Just to introduce, I'm coming from Porto. In Portugal. Someone was telling me that this is challenging to point with this pointer. So I'm coming from Porto in Portugal, and we are more or less in the opposite parts of Europe, which is interesting. So our weather is, well, I'm not saying that it's better or worse, but it's warmer, and but we are not so green as you are. So it's my first time in Lithuania. This is an image of Porto, which is a very beautiful city, and I can say that because I'm not originally from there. And this is our university. And we have there, we are a multidisciplinary campus, and there, this is the building of biotechnology where I am placed, and we have different research lines, all related with biological sciences and bioengineering. So this is our core of activities, and I'm integrated in the environment resources. So I would like to start this presentation that will talk about antibiotic resistance and the environment, so not in the clinical settings, but in the environment. And if you allow me, I would like to start with a story that I invented. Is created by me, but is very likely story, and it may happen somewhere. So imagine that we have a patient that is in a hospital, and he has an infection. He has an antibiotic-resistant infection. And the sewer will receive this bacteria because the patient is excreting the organism, so it will enter in the sewer, combined with many chemical substances that are also being used in the hospital. This goes through the municipal wastewater treatment plant. Probably this organism will survive there. Many will die, but some will be successful enough to survive, and it will end up in the environment where it will survive for sure. And then there is the irrigation of food products, and these food products are somehow capturing these microorganisms. In the second part of this story, we have someone that goes to the supermarket buying some vegetables to do a nice salad for a summer dinner, and people will get colonized with these antibiotic-resistant bacteria. Everybody will be, probably, but most of the people will have no consequences. Indeed, no one, because an antibiotic-resistant bacteria is not a pathogen. It does not give symptoms. But in some people, probably this infection is not, this colonization is not important. In others, it may be. And the grandmom had an accident, and she goes to the hospital. And there, she starts to receive some kind of treatment. And then she is very vulnerable to an infection with an antibiotic-resistant organism, and then she has a lot of problems. So this is a very likely story. So what I want to say is that antibiotic-resistant colonization is not important if we are healthy and in a good condition. It can be a serious problem if we have some medical condition, as you said, for instance, an oncological problem or an accident. So I said that I would talk about antibiotic resistance in the environment, but of course, we are only talking about antibiotic resistance in the environment because it is a clinical problem. So let's look at the data in the clinical settings. So it is estimated. It's estimation. We don't know if it will happen, and probably we can avoid that it happen. That 10 million people by 2050 will die due to an antibiotic-resistant infection. And this is something that will surpass the cancer, traffic accidents, and other kind of diseases that we know nowadays that are very, very important. But we don't have to project in 20 years or 25 years. We can consider the data now. And if we look at the data now, we see that a very large number of people die due to antibiotic-resistant infections, more than 1 million. And we have another number there that is a very meaningful number, that is almost 5 million people. They die to causes that are somehow associated with antibiotic resistance. The kind of the situation of the lady that had an accident, she went to the hospital, and since she was colonized, she was really fragile, and she had probably a bad hand due to an antibiotic-resistant infection. This figure shows us something that I would like to convey today. That is the fact that many things changed since the starting point when we started to use antibiotics. And if we see this overview that we have here, and here we have 30 years of antibiotic use, and we see a very serious change. What we see is that the situation in the beginning, it was mostly in young children. Nowadays is mostly in aged people. And we know that we are living more and we are reaching higher age, which is fantastic. But these are the population that mostly are affected by these antibiotic resistance infections. And the scenario is not very good. So this is the situation that we need to change now, because nowadays we are in 2030 almost, and we see that there will be an increase either of deaths that are directly attributed to antibiotic-resistant infections, or those that are associated because people are vulnerable. And this last group, it will increase more, even more. So this is the trend that we need to be opposed to it. We need to block and to stop this trend. This is our priority. This will be your priority indeed. Okay, how can we stop this? It's not easy. If it is easy, it would be already done. Bacteria, and normally we think about bacteria because of the bad reasons, because they are pathogens, because they harbor antibiotic resistance genes and so on. But the real thing is that bacteria are fantastic life beings. They are really fantastic, and they are fantastic because they are very good in adapting to everything. So they became adapted to antibiotics. And if we think about the mechanisms they have to destroy or to avoid the contact with antibiotic, we see 5 mechanisms. I will not go into details, but we have only 5 mechanisms. But we have thousands, millions of antibiotic resistance genes. Why? Because bacteria are always inventing and modifying their genetic information, and they are completely, all the time, they are adapting to new environments, and they are very good in doing this, and very, very fast. This is the problem. How do they do this? They do this by modifying their genetic information, by genetic mutation, but mostly they do this by acquiring new genes. What we see in this figure are cells, and this is a real photo of cells that are changing genetic information among them. And this is something that is really powerful. Think about our gut. In our gut, bacteria are very close. They are forming biofilms, so they can change the genetic information very, very easily, mostly if they are under conditions that force them to do this. So, and this is what we, in very general terms, we call selective pressure. So when they are somehow pressured, for instance, in the presence of an antibiotic, they will be incentivized to move this genetic information to the other cells. And first of all, we think, okay, those compounds that will trigger this transfer of resistance genes are antibiotics. No, are not only antibiotics, are much more than this. And this is one of the problems that we have nowadays. And when we think about all this, I don't know if you noticed that one of my first slides, I used the expression One Health. Everybody's talking about One Health nowadays. And One Health refers to many different things, but one of the things, and I will highlight this and this definition, and then I will highlight others, is the importance that in the environment, the animal health, and the human health is all combined. Okay, so we cannot consider that we can protect human health if you are not considering animal health and environment health. And what this network that was built by Julian Davis many years ago, what it shows is that indeed we have all compartments, and the ones that I have the red circle are the ones that serve as more or less reservoirs where we have the resistance, where resistance can proliferate. Okay, our gut of the animals, and these are important reservoirs. And then these, the animals and the humans have the excreta, and it goes into the environment, mainly through water, but not only through water. So we have, and we can consider that we have a generalized circle of these organisms in the environment. Is like a continuum between animals, humans, and the environment. And this network, it happens indeed in reality. If we look at this data, and it's important to look at this data and to think why, because sometimes we think, okay, we have much more antibiotic resistance now than we had in the past. Antibiotics started to be used in the Second World War in a regular basis, okay? And it was a very important moment because medicine changed after that time. Many medical interventions were possible because we use antibiotics. A small surgery, an oncological treatment, everything relies on antibiotics. So obviously we are using antibiotics much more. But if we look at these numbers, they are also informative. In 1945, we were 2.5 billion people on Earth. Nowadays, we are more than three times more. Okay? This has an impact, for sure. The population density increased 3 times or more. This obviously has an implication. So when we look at the problem of antibiotic resistance, we need to bring these things into consideration as well. We are a lot of people causing a lot of pollution, causing a lot of impact in our external environment. And obviously, there is a trade-off between these situations. We travel much more, we pollute much more, and we consume everything much more. So I think that is normal that we face some changes. Now I would like to tell you another story, but this one is a real one. This story is about a Swedish patient of Indian origin. He went to India. He had an infection. He was hospitalized, urinary tract infection. He was in the hospital, and some months after, he went back to Sweden. And it was discovered that he had an infection with an organism that contained a gene, an antibiotic resistance gene that was unknown till then. This was in 2008, okay? The next year, there was a distribution of these same genes in different countries, okay? Studies done in UK, in Sweden, and what they observed in this study is that all the people that had this gene, this same novel gene, what was novel by that time, they had been in Pakistan and in India. I'm not blaming any country, okay? I'm only giving an example how things happen. This is 1 year after. 10 years after, there was a spread all over. And one of the things, Timothy Walsh was one of the scientists who was behind all these discoveries. And one of the things that he said is that most probably this gene was spread due to the poor sewage system that exists in these areas. So it spread from the sewage system and it colonized people. And this is a real story, it's not one that I invented. So indeed, it spread all over, and this is the scenario 10 years after. Nowadays, you can find this NDM1 gene everywhere. It is everywhere. It is in the sewage, it is in surface water that is under pollution, it is everywhere. But more than this, if you see these numbers, they refer to the diversity of these antibiotic resistance genes. So not only the gene spread, to different bacteria and to different biogeographies, but also it mutated. So what was one gene nowadays is thousands of different variants of the same gene. And this is a story that is very well told for this gene, and probably it happens for many other genes, but we don't have the elements to tell this detailed story as it happened with NDM1. Just for you to inform, NDM1 is associated with carbapenem resistance. Carbapenems are one of the last resort antibiotics that we have in hospitals, okay? They are normally only used in hospitals, and they are used as a last line of defense. So this is something serious. And for instance, these organisms, when they have these genes, very often they are almost resistant to every known antibiotic. So this is something really serious. But do not be so dramatic, and I don't want to be so dramatic. So we have a lot of organisms occurring in the environment and being antibiotic resistant, but probably the possibilities that they get into contact with us are relatively low. For instance, we are not bathing in highly contaminated water, or we are not irrigated, in principle, our food with our vegetables with highly contaminated water. So hopefully the chances that we have to be in contact with an antibiotic-resistant organism are relatively low. Okay, and we must be positive in that sense. And also, if we have an antibiotic-resistant organism that enters our system, if we have a very strong microbiome, probably it will avoid the proliferation and the stabilization, the colonization of these antibiotic-resistant bacteria in our gut. So what I'm trying to say is that indeed, we have multiple barriers that prevent our contact and the successful colonization of an antibiotic-resistant bacteria. But if they are very abundant in the environment, even if the probability of getting in contact with an organism that is antibiotic-resistant, even if it is very low, if they are very common, obviously there is a burden. Okay? And even if we think about very low numbers, imagine that only 0.1% of these organisms will enter in contact with us, is still a very important number if we consider that colonization can occur. So I think that we need to put these things in perspective. Another thing that, and this is more microbiological related, is that in the previous session we saw a presentation with some pathogen and also with some what we call ubiquitous organisms. Ubiquitous microorganisms are those that can live everywhere. They can live in water, they can live in soil, they can live in a food product, a vegetable, but they can also survive if they enter our gut, for instance. These are the ones that make the bridge between the environment and the human body. And that, indeed, they are the vehicles for antibiotic resistance. And if we think about these organisms, they are not that much, okay? They belong to some groups, but for those of you that are familiar with the catalog of organisms that normally we refer to when we talk about antibiotic resistance in the hospitals, in the clinical settings, these are the names that we see. Okay, probably not so much Aeromonas, but Escherichia coli, Shigella, Pseudomonas, Acinetobacter, Klebsiella, Enterococcus. All those are very important organisms that we find in hospitals causing antibiotic-resistant infections. And those are the ones that we can find in the environment, in different types of water, even in bathing water, we can find them. Okay, not Escherichia coli if everything goes right, but all the others, they may be present in bathing water. So we are exposed to these organisms in the environment, and if we have some that are antibiotic resistant, obviously we are exposed to a problem. And this is the kind of recirculation that we are talking about. When we think and taking the possibility that the major source of transmission is through the food chain, we have something that normally we are very relaxed when we see that we don't have pathogens in water. For instance, to assess the quality of water for drinking, we use microbiological indicators. To assess the quality or in the safety of food, we measure some food safety microbiological indicators. And when they are absent, we are used to this. We are very relaxed. Oh, no pathogens here. So we assume, and this is the way we think, and well, as it can be, we assume that if it does not contain pathogens, it does not contain probably antibiotic resistance, and we are relaxed about that, which is not true. Okay, so when we think about this one health circle and where we have the environment, the natural environment, the animals and humans, we have a zone where we have like an eclipse. What do I mean with eclipse? We don't see the microorganisms. For instance, for you to give you an example, if I'm talking about the drinking water, in drinking water we cannot have Escherichia coli above 1. We cannot detect Escherichia coli in 100 mils. But if we have 1 in 1 liter of water, it will be good for consumption. It will be considered safe. Still, we have there an organism that may contain antibiotic resistance genes. So we are assessing the microbiological safety. We are not assessing or ensuring that indeed we don't have antibiotic resistance there. So we have an eclipse, and this eclipse, we think, okay, we are on the safe side. Maybe this is not the case. Why? Because if we have organisms that are not detected, they can grow very fast when they find the adequate conditions. So if we start with 10 cells is nothing in microbiology, okay? If I have 10 cells in 1 liter or 10 cells in 5 liters of water, I think, okay, nothing. But if we ingest that water in some weeks, if this organism can find a good place to survive and to proliferate, it can reach very, very fast 1 million cells. And 1 million cells is already something. So this is the kind of things that we normally, and that the microbiology still does not address, is these eclipse zones that we have in the environment. Okay. Another topic that I would like to bring to your attention is that antibiotic resistance is not uniform around the world. If you look at this map, what you see is that Europe, for coincidence, Portugal is not very well in this picture as well, but and we have a serious problem of antibiotic resistance. But what we see is that indeed we have very important asymmetries around the world. And if you see, we see Africa, we see Asia, and we see Latin America. They are the weakest parts in this map. And there are some studies that use something that is nowadays very popular, that is the wastewater-based surveillance. Basically, what is done is it was popularized. It did not start with that, but it was popularized with COVID. And what is done is to take sewage, the municipal sewage, and to measure there the pathogens, and in this case, antibiotic resistance, as a measure of the prevalence of that pathogen or antibiotic resistance in the population that is served by that sewing system. And the colleagues of Denmark, of the Technical University of Denmark, they did this analysis, and what we see here is that we don't have antibiotic resistance prevalence is not distributed in an homogeneous way. We see that indeed Europe, North America, and Oceania, they are the ones that are, well, in a very comfortable position, at least if we compare with Africa, with Asia, and with South America. And this is something that has a meaning, and we must understand why is this. And there are several reasons for that. One reason, and now don't forget that I'm trying to discuss why antibiotic resistance is not similar around the globe. One difference that is important is the temperature, okay? And different studies have been showing that we have more antibiotic resistance in areas with warmer climates. And we are also talking a lot about global warming. So this is something that we need to pay attention. So the warmer regions in the globe are also those regions where we have, more antibiotic resistance. So there is a climate factor that is important. But there are other reasons. Another reason is this one, is that we live in the era where we have Artemis 2 and we go to the moon, but we still have a lot of people with no access to safe sanitation. And these numbers are not negligible. We have more than 40% of the people do not have access to safe sanitation. And this is something that has a terrible impact in the environment. And the amount of antibiotic-resistant organisms that is being, because these regions are the same regions where, for instance, there is no mandatory prescription of antibiotics. In many of these regions, the antibiotics are free. Okay? So there is a combination of factors that are very important here. And now we have the problem of pollution. Pollution is not only related with the absence of proper sanitation, because in our primary settings where we have wastewater treatment, we also pollute a lot, but the pollution that we have is completely different from the pollution of the low-income countries. So we have different patterns of pollution in Europe and in high-income countries and in low-income countries. And indeed, we have a lot of pollution that is caused by antibiotics, and of course, this causes a selection for the microorganisms. But recently, what we saw is that many substances that are not antibiotics, but that are pharmaceuticals that we use, and even non-pharmaceutical, I'm thinking about the sweeteners, artificial sweeteners. All of these, they are demonstrated to have an effect on the promotion of antibiotic resistance. So we have many things that are contributing. Is the warming, is the poor sanitation, is the pollution. We have many factors that indeed are fueling this situation. And we see here again a map now to show where do we have more pollution in water and more chemical substances that are that should not be present in water, but they are. And if you see, we have a lot in Europe, even despite our good sanitation systems, but we have, of course, a very serious situation in South America, in Asia, and always the same regions are the most affected. Okay, here we don't have data for the southern part of the South America, but for sure it is a situation very dramatic. And there is another factor that is also very important, is that we are losing in some regions of the world, we are losing the dilution capacity. What do I mean with this? When we have pollution that is being emitted into the environment, if we have rivers that are very healthy with a lot of water, with a very strong water flows, the pollution will be diluted and it will not exert a very selective effect. But in many regions of the world, and probably you don't face this problem here in Lithuania, but if you go to Southern Europe and to Western Europe, you will see that we have water scarcity, and in some places, and I'm talking about Europe. I'm not talking, for instance, about Africa. We have regions where the wastewater treatment plant discharges into a river, and the river is completely dry, has no water in the summer. So all the water that is arriving there is indeed wastewater. And this water will be used to irrigate some tomatoes, some lettuce that is downstream. So this is a real situation, and this is also a problem. So what I'm trying to say is that indeed we have many factors that all are contributed to something. And this is a study by Peter Collignon in Australia. It's a very nice study. He tried to understand the multiple factors that contribute to antibiotic resistance, and also corruption, education, or poor education. Many factors are observed to be associated with increased antibiotic resistance, at least in some world regions. Okay, and now we have, I don't like to be catastrophic, and I don't want to be, but we have several other factors. We have refugees, we have wars, we have the climate change, which brings a lot of floods and droughts. All these are important factors to spread antibiotic resistance around the globe. So this is something that indeed is fooling all this situation. Okay, but this is a Hesher slide. It's very, you can see there many different perspectives, and I think and I hope that you think about antibiotic resistance in different perspectives, because it will help. And there has been a very important effort over the last years about the Sustainable Development Goals. And this is a very idealistic agenda established by the United Nations. It's so idealistic that we are almost in 2030, and we are very, very far from reaching most of these objectives, or probably all of them. But they have a merit, and one of the merits that we see here is that indeed it makes us think about some things, about fairness, about equality, about gender balance, which is also a very trendy topic, about human health, sanitation, and so on. And if we think about these Sustainable Development Goals, we see that most of them, they have some kind of impact on antibiotic resistance. And we may think that if we have less polluted, less corrupted, less many other things, if we decrease the inequalities, probably we would have lower antibiotic resistance. Probably we would not solve the problem, but we would have less problems. And because antibiotic resistance is not a problem alone, it's the consequence of many different things, as I tried to show. So I think that this is something that we need to have in mind. Okay. This is the same picture that I showed before, but now with a different perspective. And many things, and when the research on antibiotic resistance started in the environment, I mean, it started probably to be very popular in the last 15, 20 years. And many important things were made since then. We do not have to consider that everything is a disaster and many things are wrong and so on, because I think that a very important effort was done to improve the antibiotic use. Many important improvements were made, at least in Europe. We have the European Centers for Disease Control and Prevention, which made very important improvements on the antibiotic use. Also on the surveillance in the clinical settings, and I think that every country can have the data about the evolution of antibiotic resistance. And we see, for instance, in Portugal, it was clear that we could decrease the resistance of some pathogens, namely Staphylococcus aureus, in the hospitals. So this is something that is indeed very important. For surveillance and monitoring, we have now a new legislation of the wastewater treatment directive, in which is included the monitoring of antibiotic resistance. So this is an important step forward. And the European Commission is making a lot of efforts to monitor antibiotic resistance in the environment, not only in sewage, but also in rivers, and to see the impact. And this is something that is moving forward. So we are giving very important steps, and I'm giving the example of Europe, but I believe that in the United States, maybe also we are now in a different phase of the United States, but in Australia, in many regions, I think that there is the awareness that antibiotic resistance is important and that indeed it is necessary to do something. For instance, another important step was the use of antibiotics for animal production. Antibiotics were used to grow animals for food production, and this was a normal practice and is still in South Africa, in China, in the United States, but it was banned in Europe. So and is banned for 20 years now. So important steps have been given. So I think that we are in the right direction. But there are many things, and most of the controls have been made in humans and in animals. So I think that important steps have been made. But nowadays, I think that we are at a different stage of the things. And one of the things that probably we have to consider is that I think that all of you are familiar with the word omics. Omics meaning the global thing, the whole thing. And I think that also for antibiotic resistance, we need to consider the whole thing. And what do I mean with this is that if we have an environment that is more resilient, probably it will not be so permissive to the proliferation of antibiotic-resistant bacteria. If we have our own microbiomes, if they are stronger, probably they will not be so vulnerable to the proliferation of antibiotic-resistant bacteria. So probably we need to change our mindset and work much more on the ecosystems and not only on the antibiotic-resistant organisms and the pathogen perspective. So I think that is time, and nowadays we have knowledge because we have a lot of knowledge on genomics nowadays, even for individual pathogens or for the microbiomes. So I think that probably we now can change our mind in that aspect, because the formula that we have before, looking for antibiotic-resistant bacterial genes, is not enough. It does not work. So we need to change something. And there is something that is probably where the most important decisions lie, which is in the communication. And because for instance, today I'm talking with you. Most of you are probably related with the sciences, and you understand what I say. But probably if you go to a parliament, if you go to people who make the decisions, they are not aware of this situation, and probably they are not aware of the kind of solutions that can be implemented. And this is where things normally fail. For instance, in the clinical sector, a lot of improvements have been made because there was a lot of pressure into the authorities and the entities that make the rules. And for environmental matters, we are in the infancy of this kind of intervention and interaction. And this is my last slide. And I would like to come back to the One Health definition. I defined One Health definition, One Health, as the how the environmental and animal health impacts the human health. And this is a possible way to look at One Health. But indeed, One Health is the multisectoral action, which means that we have everybody seated at the same table discussing the same issues. And I work in the field of antibiotic resistance for more than 20 years, as I said. And for instance, the methods that we use in the environment and the ones that are used in clinics are different. The dialogue between people from the clinical settings and the environment do not exist. This dialogue does not exist. For instance, when we have hospitals, and we have very big hospitals, central hospitals, they are discharging most of in most of the places around the world, they are discharging their effluents into a municipal wastewater treatment plant. Okay? And many people say, okay, it doesn't matter because it's probably 1 to 5% of the sewage that is entering in the system. It's irrelevant. It's not. Because in the hospital effluents, we have genes of antibiotic resistance and bacteria that are highly prevalent in these hospital effluents, and they would not reach the environment if they were not mixed with the municipal, the domestic wastewater. So these kind of measures, why is this not popular? This is not popular because if we have to design an infrastructure in the hospital to have a sewer that treats these effluents and that makes a proper treatment of these effluents, we are increasing a lot the costs of operation of the hospital. Okay, so, and these are, I'm not saying, and I'm not blaming anyone, I'm not saying that this is a easy decision, but it's a multisectoral decision, okay? And probably the problems that would be saved by doing this, it would probably compensate to have this kind of perspective. So, my message, and I think this is the message that all of us need to have in mind, is that indeed it's important to have a dialogue. And sometimes dialogues, I was discussing with someone how sometimes it's challenging to do interdisciplinary things. To talk with someone from physics. Probably I don't understand what you say, you don't understand what I'm saying. So this is difficult. And if I'm talking with a politician, it's even more difficult. This is very difficult, but we need to overcome these barriers because this is where the problem lies, because people are not working together indeed. I invite you to see this website when you are in a good mood, but be in a good mood. This is personal testimonies of people who got antibiotic-resistant infections, and how hard it is to get rid of them. They are told by the people who suffered this. Be sure that you are prepared to see it. Okay. I also have an invitation for you. We are making a survey about the possibility of getting an antibiotic-resistant infection from the environment. So please, this is the QR code for the query. Please spread it. We have some answers from people who do surf, who swim in open waters, who do farming, who travel a lot. So we are interested in hearing this. Your help will be much welcome. I have a question for you. This is for you to think about. If you were going to design the healthcare for in 20 years, what would you change to avoid this problem? It's a very difficult question, but I'm sure that you have the answer. Not now, you can think about it. But yeah, I think that the young generations are the one that can make the difference. We always think that is normal. The older people always think that the next will make a difference. And yeah, it is like that. Okay, this is my my colleagues and some friends. This is Porto. This is the river, Douro River. This is the mouth of the Douro River, and Douro River is where the port wine is produced. Okay, it's in the mountains. And okay, an invitation for some of you. The UMS conference, the International Union Microbiology Society conference, will be in Lisbon in November 2026. The deadline for abstract submission ends in May 6, I suppose. So if you have some burning things, or even if you don't, go there. Lisbon is very nice as well. Okay, and some acknowledgements. And that's it. It was a pleasure, and I'm looking for your questions.
Thank you very much for such an inspiring presentation and scaring and shaking us a bit. So please, do we have any questions in the audience?
Thank you very much for a very eye-opening presentation. I wanted to ask about the trend you showed at the beginning of the presentation, where we had like straight line of till the corona pandemic started, and just a bit of dip, and then it started to spread, like to go up very rapidly. What was the cause for in the calculation?
I think is not. This is a publication in the Lancet journal, and I think the change is not the pandemics, is because the study was launched in. It took data till 21, indeed, 21. So, but I think it's not related with pandemics. Is related to the fact that they are making an estimation, and while they are making this estimation, they are obviously establishing the worst case scenario, and that's why we have.
It's okay.
It's an alarm that was planned. Yeah, I was informed about that.
It's just a test of the security system in Lithuania.
Hope we don't need to do anything. Yeah, yeah, but I think this they are making the worst case scenario, and I think this is the reason why it is increasing so sharply.
Okay, thank you.
Yeah.
Thank you. I see the question there.
Thank you for this wonderful talk. I wanted to ask, perhaps you could share what are some little habits each person could acquire in their everyday life to help make a change and mitigate this grave problem?
Well, I think that something that all of us can do. Should we wait? I think that something that all of us can do is to, well, there are those classical things like using the antibiotics only when they are prescribed, use them as they should be used. But I think that we can do more and take care. All of us are pollutants. We are not pollutants, polluters. All of us are polluters. So I think that we need to be aware of this and to change our habits a lot.
Yeah, so to recycle more, maybe
Recycle
save
more,
energy.
use less disposable things. We use a lot of disposable things. Use less chemicals. We use a lot of chemical, not only pharmaceuticals, but we use a lot of synthetic chemicals, and we are creating a very important pressure in our ecosystem. One of the things that emerged in this wastewater treatment directive was the principle they tried, and I think it will not succeed, try to implement the polluter pay principle, which means that a company that is producing a chemical compound, it will somehow be part of the treatment process for the removal of this chemical in the environment. And this is a good principle, but probably it will not apply because there was a claim and the companies are not available to do this. But this is a recognition that many industries, they are producing chemical compounds that they are polluting a lot in the environment. Because, for instance, you can have a medical formulation or an alternative, and an alternative can be readily biodegradable, and the other one is not biodegradable. So probably you should use that one and not the one that is recalcitrant. So these kind of options is also important. But it relies on a lot of awareness of the people, which sometimes is not the case.
Yes, okay, thank you so much. I hope we all can change our mindsets.
I hope so. I hope so.
Thanks a lot for a wonderful presentation and for painting this very complex picture of AMR. I'm just wondering where the development of new AMR drugs or new antibiotics, new drugs, or like new ways to treat infections in general, talking about phage therapy and so on, where does it fit in that complex picture, and does it have a role there?
Yeah, there are new solutions for some kind of infections with phages, but they are mostly used in very topic and well-defined infections. But this is an option, and that is making producing very nice results. For instance, in skin infections, or in the case of patients with cystic fibrosis is being used. Another strategy is the fecal transplant in cases of situations where it is impossible to remove mainly Clostridioides difficile, which is an organism that is in the intestine. And sometimes these are not antibiotic-based therapies, and they are very successful. But obviously, they are only used in very specific situations. I would like to believe, and I believe, that probably our knowledge of genomics, of bacterial genomics, where we can know exactly what make a pathogen survive and proliferate, probably we can do some drugs that are not antibiotics, and they are somehow blocking these metabolic pathways. But as far as I know, I think we are far from that. Even the RNA interference technologies, the small RNAs, they could be indeed a solution, but the liver systems and many other things are blocking still this. So from what I have seen, there are not much disrupting ideas for treating bacterial pathogens, as far as I know.
Thank you.
Thank you for your talk. And actually, my question was answered because as far as I'm informed, in Portugal, it was recently approved, the phage therapy.
Yes.
So maybe we're not as far from these alternative treatments, and I was wondering, what do you think about the fact that phages, they are also changing, and potentially, let's say, I've heard the stories when we had, let's say, biological treatments for plants, when we used bacteria and then they mutated, and let's say something that we cannot control, and many strategies against bacteria when it comes to like very biological way to solve them, we cannot truly control. And do you think that phage therapy also has this issue?
Thank you very much for your question. I see that you are very well informed. And this case of the approval of phage therapy in Portugal is a very interesting situation because it was a young lady with a cystic fibrosis. She was 25, and she started a petition, a public petition, to the approval of phage therapy because she was always in hospital with antibiotics and a lot of problems. And she triggered the process, and she was very successful. So this is one of the examples. Thank you for bringing this. This is one of the examples that shows that people, when they want, they can trigger the things, and they can make the change. And this change was triggered by this lady, by this young lady, that she was suffering, and she started the process. Regarding the phage therapy, it is very successful in these very specific situations, and I think it is why it is used for very specific situations, because obviously the phage and host of the phage, they can mutate both, and they can co-evolve, and everything will be destroyed in a very fast time. When I started hearing about phage therapy, it was a group in Finland that was trying this in aquaculture systems. And in aquaculture systems, the microbiota is too complex. So phage therapy does not work in such complex systems. I think it works very well if you have a pathogen and you have the phages that are, and you can control, and sometimes it is combined with antibiotics. So it's something that needs to be really very well controlled. Otherwise, I think it fails. But it is a very promising, and there are many companies starting to produce phages for therapy. So it's a promising field in a very specific niche for application. Yeah.
Thank you for your answer.
Okay, do we have the last question? If not, so thank you very much one more time. Enjoy the stay in Lithuania, and for all of the audience, enjoy the rest of the conference. Thank you.